Welcome to EDU World Space.
So in this problem, we have to find the spacing between planes in the diffracting crystal. Given the kinetic energy is 72 electron volt and the angle at which the first order peak is observed is theta, 38 degree. Now, since the electrons at this energy are non-relativistic, we can write the kinetic energy to be p square over 2m. This gives the momentum p to be equal to root over of 2 times mass times kinetic energy. Now from equation 25, we know that lambda is equal to 2d sine theta, where d is the spacing between the planes. That means d is equal to lambda over 2 sine theta. Also, from equation 27, 8, we know that the de Broglie wavelength or lambda is equal to h over p. Now, using the value of p from here, we get lambda to be equal to root over of 2 times mass times kinetic energy. Now, we can substitute this value of lambda into this equation and we get our d to be h over 2 sine theta root over of 2 times mass times kinetic energy. Now we know that mass is the mass of the electron, which is 9.11 times 10 to the power minus 31 kg. H is the Planck constant, which is 6.63 times 10 to the power minus 34 joules second. Now let me move this thing to here. So then our d will be 6.63 times 10 to the power minus 34 joules second over 2 times sine 38 degree multiplied by the root over of 2 times 9.11 times 10 to the power minus 31 kg times the kinetic energy. Now we need to convert the kinetic energy from electron volt to joules. So this will be 72 electron volt times 1.6 times 10 to the power minus 19 joules for electron volt. Then we solve it and we get d to be 1.2 times 10 to the power minus 10 meter.